Hi friends, good morning. Today we are going to discuss with another section of differential equation. So in previous class we seen how to solve a differential equation using series solution method, right? Now as a continuation, today we start with the special differential equations, right? First one is Hermite differential equation, right? So Hermite differential equation. See, Hermite differential equation represented like this, right? A higher order differential equation. We have seen higher order differential equation, right? Any higher order differential equation coming in this particular format, that is d square y by dx square minus 2x dy by dx plus 2n by is equal to 0, right? Where n is any arbitrary number, right? Based on the n value, we have different solutions, that and all we study, right? So this format is very important, right? This kind of differential equation is known as Hermite differential equation, right? Now, how to solve this differential equation? We studied in the previous class, we consider a series method of solution, right? We imagine y is equal to sigma n is equal to 0 to infinity n x raised to n, right? Now we find a y dash and a y double dash, and that value, this y value put here, and by differentiating this y dash value you put here, and by double differentiation by double dash value, and then you generalize the expression, right? That method previous class we already seen, so I am not going to explain, we directly go to the solution, right? So using series solution method, if you solve this differential equation, you get the solution like this, right? This is the solution of different series solution, right? Then the solution of this differential equation you can represent as hn of x is equal to r is equal to 0 to this n value varying from r value is varying, here a variable r you see, this r value is varying from r is equal to 0 to greatest integer n by 2, right? I will tell you what is this very accurately. Minus 1 raised to r n factorial r factorial n minus 2r factorial 2x raised to n minus 2r, right? For example, I want to find h1 of x, right? h1 h0 of x, right? First Hermite differential. h0 of x means in the previous differential equation what we studied, d square y by dx square minus 2x dy by dx plus 2ny equal to 0, right? Here n is equal to 0 means this is changed into a h0 of x, right? That is the, then h0 of x, what is the solution? Put r is equal to 0 to, here 0 by 2 is 0, greatest integer function of this greatest integer of 0 is 0. What is greatest integer of 0.5? That also 0. What is greatest integer of 0.9? That also 0. Greatest integer of 0.1 to 0.9, that is equal to 0, right? Now greatest integer of 1.2 what? Right, that is 1 only, right? Greatest integer of 1.9 also 1 only, up to any number after 1.1, 1.2 up to 1.9, its value 1 only, right? Alright, so look here, so h0 of x, how we solve, that is equal to sigma r is equal to 0 to this value also 0, then we need not write this, because r value 0 to 0 only, then h0 of x means n 0, r also 0, right? Now how we write? Minus 1 raised to 0, 0 factorial because n value 0, r value also 0. 0 factorial, 0 minus 0 factorial, 2x raised to 0 minus 0, right. Then minus 1 raised to 0, 0 factorial, everything 1, 2x raised to 0, that also 1. Then answer is 1, right. This is the value of h0 of x, right. Now what is h1 of x? h1 of x means put n is equal to 1. Here 1 come, right. Here 1 come, here 1 come, here also 1 come, right. R value is varying from 0 to 1 by 2. Greatest integer function of 1 by 2 what? 0.5. That is again greatest integer of 0.5 is 0 only, right. Alright. Up to 0.9 its value is 0, right. So R value again 0 only, but n value is 1 only. Then what is h1 of x? h1 of x is equal to minus 1 raised to r value 0 only, n value 1 factorial, 2x raised to 1 minus 0 divided by r value again 0 factorial, 1 minus 0 factorial, right. Alright. So this is this term 1, this term 1, this term 1, this only exists 2x. Then what is h1 of x? h1 of x is, that is 2x, right. Now let us find h2 of x also. First 3 value we can find. Suppose you are finding 2 here, right, h2 of x. Then here 2 by 2 come, then r has 2 values, r is equal to 0 to 1. Then 0, 1 come. Here n again 2, here this n 2, this n also 2. Now we can substitute value h2 of x. First put r is equal to 0. R can take value 0, 1. R is equal to 2 by 2, 1. Greatest integer of 1 is 1. Alright. So let us substitute that value. Minus 1 raised to 0, 2 factorial divided by, right, 0 factorial into 2 minus 0 factorial and 2x whole square, right. Plus now let us put r is equal to 1. Then minus 1 raised to 1, 2 factorial divided by 1 factorial into, right, 2 minus 2 factorial and 2x raised to r is equal to 1, 2 minus 2. Then this part we can write as 2 factorial, 2 factorial, 2x whole square, 4x square, right. Minus 1 raised to 1 minus, and here 0 factorial, and here then 2 factorial only pending. This also 2x raised to 0, 1, then 4x square minus 2, right. So we found h0 of x 1, h1 of x we got 2x, right. h2 of x you get a 4x square minus 2, right. So this is the first 3 Hermite polynomials. Okay, let us see, right. So let us go to see. So we solved the h0 of x, that is 1, h1 of x, that is 2x, h2 of x is, that is 4x square minus 2. Alright. Now similarly, see h3 of x you can calculate, right, 8x cube minus 12x, and h4 of x you can calculate 16x raised to 4 minus 48x square plus 12. Okay, first 3 value you should by heart, and if any other values asked means we can find from recurrence relations. We have a lot of ideas to find different higher order values of Hermite polynomial, right. We will discuss, right. Now let us go to another section. See, so what you have seen, h0 of x we seen this 1. Then see, look here, after 0, this is the 0th line, right, and here 1, at 1 a straight line you see. So that is representing this line representing that line 1, h0 of x is equal to 1. Now h1 of x is equal to 2x, that means another straight line with a slope, that is this line. You can see another line, right, This is h1 of x is equal to 2x. Now h2 of x, right, that is a quadratic term, right? So there is a parabola, right? So that is a quadratic term only. So which is the parabola representing? See, look here, one parabola here, right? So similarly, based on the function value, now next is a cubic polynomial. Cubic value representing like this only, right? See, right? So based on the function value, we can plot different Hermite polynomial, right? So like this, right? All right. Now let us go to another section. See, generating function. What is generating function, right? See, generating function means, let me take a pen. All right. See, e raised to, for a generating function of Hermite polynomial, you can write as e raised to 2tx minus t square. All right. E raised to 2tx minus t square. All right. Now, suppose you expand this using Taylor series expansion, then what you can write? Hn of x you can write as n factorial into coefficient of t raised to n. This is the formula, right? See, from this function by expansion, you can write hn of x as n factorial into coefficient of t raised to n. Right, you can verify that. See, look here. So let us verify that. See, what we studied h0 of x. See, what we studied h0 of x, what we studied 1. h1 of x, what we studied 2x. h3 of x, what we studied 4x square minus 2. Alright, this and all we studied. Now from this expression we getting it or not, right? See, what is e raised to 2tx minus t square, right? That I can write as e raised to minus t square. That is, what is e raised to 2? E raised to x generally 1 plus, right, x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. This is the general expression for e raised to x. Then I am expanding this 1 plus 2tx divided by, right, 1 factorial plus 2tx whole square divided by 2 factorial plus 2tx whole cube divided by 3 factorial plus etc. Right, into, and e raised to minus t square on expansion 1 minus t square by 1 factorial plus t raised to 4 by 4 factorial minus etc. Right. Now, as per this rule, right, see, h1 of x, what I can write? See, what we studied? hn of x is equal to n factorial into, that only telling, coefficient of t raised to n into n factorial is equal to hn of x, then coefficient into coefficient of t raised to n, right? Now look here, by multiplication h1 of x is equal to 1 factorial into, that is n factorial, coefficient of t raised to 1. Here 1 factorial means here t raised to 1. What is t raised to? By multiplying 1 into 1, right? So first we can write h0 of x, right? We can find out h0 of x. Then what we write? 0 factorial into t raised to 0 coefficient. Which is t raised to 0 coefficient in this? By multiplying this 1 into 1, you get 1, right? Then 1 into t raised to 0 only 1. That means t raised to 0 coefficient what? 1. Then t raised to 0 coefficient is 1. 0 factorial 1, 1. Then look here, h0 of x you are getting 1. Now you can find h1 of x, right? h1 of x. then 1 factorial into coefficient of t, right. See, look here, in this expression 1 into 1 we are done. See, this term you multiply with this one, then you will get a coefficient of t. Coefficient of t is 2x, right? Then into 2x, then you get a h1 of x 2x. So h1 of x is 2x, right? This is the method. Now h2 of x, right? h2 of x we can write, right? That is 2 factorial into coefficient of t square. That is 2 factorial into coefficient of t square. See, this multiplying with this 1 t square. Then here 2x the whole square, that is 4x square by 2 factorial. 4x square divided by 2 factorial, that is one part. So by multiplying this with right 1. Now look here, by multiplying 1 with this minus t square by 1 factorial, you get another coefficient of t square. What is that? 1 only, right? Minus 1. Then minus 1 by 1 factorial. What is this? 2 factorial, that is 2, and here 2, this cancel, then 4x square, and this 2 factorial into 1, that is minus 2. 4x square minus 2. Alright. Now look here, h3 of x, 4x square minus 2. Right. So that is why we call it as this function as generating function. Right. From this you can find the hn of x values. Alright. Alright. Now let us go to another section. See, Rodriguez formula. Right. That also very important. We can verify that. See, what we studied. See, what is h0 of x? You can verify. Rodriguez formula means a differential equation used to find the Hermite polynomial value. See, you know h0 of x is equal to what? 1. Or h1 of x what? 2x. h3 of x what? h3 of x 4x square minus 2. This all we studied, right? Alright. Now we can verify this. Put h0, n you put 0. This minus 1 raised to 0, e raised to x square into d raised to 0, dx 0, e raised to minus x. Then this part is no differentiation. This means no differentiation. Then minus 1 raised to 0, 1, e raised to x square into e raised to minus x square, what? This cancel, then 1 only. So from this you are getting h0x very directly 1. Alright. Similarly, h1 of x also we can find. H1 of x value what? 2x. We can find out that. See, look here. Here you put 1. Minus 1 raised to h1 of x. Right? That is put n is equal to 1. Minus 1 raised to 1 e raised to x square d by dx of e raised to minus x square, right? So this is, right, minus 1 raised to 1 minus e raised to x square into d by dx of e raised to minus x square. E raised to x square differentiation, e raised to minus x square only. Now you have to differentiate using function of function rule, minus x square on doing minus 2x. Now this and this, right, 1 minus into minus 2x, 2x. Now you are getting the value, right? h2 of x we studied 2x only from this equation. That's why this is called as Rodriguez formula. That means a differential equation corresponding a differential involving term that is helped to find a Hermite polynomial value, right? Alright. Now next is, see, hn of x, its value hn of 0 is 0 for n is odd. It's correct only. Look here. What is, you studied h0 of x, right? Sorry, we studied h1 of x, h0 of x, that is 1, h1 of x, that is what? h1 of x that is 2x, right. Now h2 of x that is 4x square minus 2. Verify. See, if n is odd, that means here n odd, n is equal to 1 means this is odd. Now if n is odd, hn of 0, see here h1 of 0 what? Put x is equal to 0, then here also 0, then its value is 0, right. Understood? Then this is a rule, hn of 0 that is 0 for n is odd. Now let us, if n is even, you can look like this, look minus 2, suppose I need to find the h2 of 0, h2 of 0 what? Right, here put 0, its value is x0 means minus 2. Let us verify this by this formula, minus 2 by n by 2, right, sorry, so h2 of 0 only, then n is equal to 2, right, 2 divided by n minus 1 double factorial, that is 2 minus 1 double factorial, then minus 2 raised to 1, minus 2 raised to 1, 1 double factorial is 1 only, that is minus 2. Here also we got minus 2, right? Understood? So these values, right, it is possible to execute, right? Similarly, h2n of 0, you can find this formula also. Suppose n is equal to 1, then h2 of 0 you find, you get a minus 2. For example, suppose n is equal to 1 in this, then what is h2 of 0? h2 of 0 is minus 1 raised to 1, 2 into 1 factorial divided by 1 factorial. What is this value? Minus 1 raised to 1, that is minus 2 only. See, minus 2, right. So this is also correct, right. This h2n plus 1 of 0 is 0 means we already studied, for n is equal to odd value, this h1 of 0 is 0, right. It is another way of 2n plus 1 represents odd values, alright. Alright. Now orthogonality relation, right. See, orthogonality relation, that means minus infinity to infinity, hm of x, hn of x is equal to root pi 2 raised to n factorial into Dirac delta of mn, right. Now understand, Dirac delta of nn is equal to 1, Dirac delta of mm is equal to 1, because both index same means Dirac delta function value 1. If both index is different means its value 0, right. So m and n equal, that time its value is 1. So we can verify. For example, we can take, see, so for here m I am putting 1, n I am putting 1. Then LHS I am calculating. LHS what? LHS is equal to integral minus infinity to infinity dx e raised to minus x square h1 of x into h1 of x, right. Then LHS I am solving first, that is integral minus infinity to infinity, right. h1 of x what? h1 of x is 2x, h1 of x again 2x, right. h1 of x value we derived 2x, right. Then what I can write? 4x square e raised to minus x square dx, right. That is 4 into this minus x square is a even function, right. This variable has square, that means that is an even function. Even function means I can write 2 times integral 0 to infinity. 2 times integral 0 to infinity, the same value, right. That is x square e raised to minus x square dx. Now I am writing one formula, integral 0 to infinity. In quantum mechanics, we studied this formula, right? I think you are remembering, right? See, x square x raised to 2n e raised to minus ax square equal to 2n minus 1 double factorial into 2 raised to n plus 1 a raised to n root pi by a. This is that formula. Right. See, now here you substitute that value 4 into 2, that is 8. And what is this value here? Instead of a, we have 1 here. Instead of n, we have 1 here. Then we substitute that value here. N is equal to 1 means 2 minus 1 double factorial divided by 2 raised to n plus 1, that is 2 square, and n is 1, that is a. A is value again 1, then root pi by 1, that is what? So 2 root pi, 2 root pi, right? Now RHS you calculate. RHS you calculate, right? What is RHS? RHS is root pi, right? 2 raised to n, that is 2 raised to 1, because we put a 1, n value 1, n factorial, 1 factorial, delta n1, m1, n1, then delta 1. Now delta 1, 1, if both indexes same means its value 1, right? Then what I can write it? 2 root pi. See, same value you are getting, right? So this is the orthogonality relation. Any Hermite polynomial, you can put a 1 here, 2 here, you can check, right? Then 1 here, 2 here you put means m not equal to n, that time this value you are getting 0, you can verify. Okay, you have to check it, right? Alright. Now let us go to, see, recurrence relation. Recurrence relation means different Hermite polynomial with various index connected by different formulas. That is actually recurrence relation. You can verify this also. We can verify, right? See, look here, 2xhn. If this is correct, for any n value it is correct. Put n either side you take 1. Okay. Okay. N either side you take 1 means what? LHS what? LHS. Here first relation is this 2xhn minus 2n minus 1 equal to hn plus 1. See 2xhn, 2x h0, put I am putting n is equal to, sorry, n is equal to, I am taking a 1, right? So LHS, that is 2x h1 minus 2, n I am taking 1, right? Then 2h0, right? Here I put n is equal to 1, that is 2x into, what is h1? h1 is 2x. We already know h0 of x is equal to 1, h1 of x is equal to what? 2x, h2 of x is equal to what? 4x square minus 2. This and all we studied, right? Okay, 2x into 2x minus 2 into h0 what? 1. Then what? 4x square minus 2. Now what is RHS? N is equal to 1 is h2. h2 value what? 4x square minus 2. That only we getting here, right? So this equation is valid. Now next here, see, put h, see, look here, put n is equal to 1 either side, right? See, h1 of x what? That is 2x. Then h1 dash of x what? That is 2. Then LHS. LHS I calculate. Now RHS what? 2x, right? h1 what? That is 2x, right? Minus hn plus 1, right? Here put 1, then h2. This is what? h2. This is what? 4x square minus 2, right? The hn plus 1 is 1 given h2. h2 is 4x square minus 2. Then 4x square minus 4x square plus 2. This cancel. Then RHS also you getting 2, right? This equation also valid, right? Now this one also you can prove like that. Put again h dash n. Okay, I put n. Then h dash 1 here I put, then here 1, here 1 minus 1 0. Now this is 2. Now 2 into h0. Right. What is h0? h0 is 1. h0 is 1, we know 2. Then this also 2. Right. So these equations all are valid. Right. But in the examination point of view, you have to by heart these relations. Right. We are deriving this whole relation practically not possible. Right. Or from the given equation by substituting some index values which is appropriate, which is true, like that also we can check. Right. All right. Now, so let us do some question. See, look here, some information is given. Second derivative of Hermite polynomial minus 2x dh raised to n by dx 2n hn x equal to 0. Right. Now, which is this corresponding differential equation? Right. So, we know the generating function. Right. So, look here, generating function they given n factorial into hn of x t raised to n. So, g I am taking 1 by n factorial into hn of x t raised to n they given. Then we can substitute what is g dash. G dash is equal to 1 by n dash, 1 by n factorial h dash n of x t raised to n. Now what is g double dash? 1 by n factorial, right, into h n double dash of x t raised to n. Now they are this is dou g by dou x square we find with respect to x. Now another term dou g by dou t also option coming. What is dou g by dou t? Dou g by dou t is equal to that is differentiating this 1 by n factorial hn of x into with respect to t, then n t raised to n on doing n t raised to n minus 1. All right. Now we are substituting this value in different option. Right. So if you substitute here means dou square g by dou x square what? So let me substitute here. Dou square g by dou x square I am substituting, that is 1 by n factorial into h double dash n of x t raised to n. Right. Dou square g by dou x square I substituted minus 2x into dou g by dou x is what? 1 by n factorial into dou g by dou x is h dash n of x, h dash n of x, right, t raised to n, t raised to n, right, plus 2t into dou g by dou t. Dou g by dou t we already written. Then 1 by n factorial into hn of x into, right, n t raised to n minus 1, n t raised to n minus 1. Right. Now you can take a common term out. Right. See what and all common term? 1 by n factorial t raised to n. T raised to n by n factorial, that is common everywhere. Then h double dash n of x minus here 2x, right, t raised to n hn of t raised to n by n factorial 2x hn dash x. Here t raised to n by n factorial going out means this t and t raised to minus 1 go, right, then t raised to n by n factorial is 2t dou g by dou t, right, that is 2n hn of x, right, 2n hn of x, right. Now look here, this part they already given, this part you look already they given as 0, then this value is what? 0, right? Then option A itself satisfying the condition, right? By substituting this bracket term already they given us 0, that we extracted, then that value is 0 means this value is 0. Then you need not check this. Here t square only coming, different option given. Option A itself correct. Alright? Alright. Now let us go to another question. See, now the question is, the generating function they given us, given that is sigma n is equal to 0 to infinity, hn of x t raised to by n factorial is equal to e raised to minus t square plus 2tx, the value of h40, right? What is h40, right, is equal to what? 4 factorial into coefficient of t raised to 4. This only we studied, right? Now, our generating function what? E raised to minus t square plus 2tx. This only hn of x, right? Now, in this expression, the coefficient of t raised to 4 we have to put, right? So, here hn of 0 means generating function changes to x is equal to 0. That means e raised to minus t square, right? What is e raised to minus t square? Expansion 1 minus t square by 1 factorial plus t raised to 4 divided by 2 factorial. Then in the expansion, what is the coefficient of t raised to 4? Plus etc. 2 factorial, 1 by 2 factorial. Then 4 factorial into 1 by coefficient of t raised to 4 what? 1 by 2 factorial. What is 4 factorial? 4 into 3 into 2 into 1 into 1 by 2, that is 2 cancel. 4 into 3 what? 12. Then which is the option? Option A is correct, right? Alright. So this is all about a Hermite differential equation session. Now tomorrow or day after tomorrow we discuss with the Legurier differential equation. Alright. Thank you.